It's now firmly established that supermassive black holes reside at the center of most every galaxy and shape many of the observable characteristics, such as the glow of the central bulge, the composition of the galactic halo, and the jets observed emanating from some quasars. These characteristics were first pointed out by the United Kingdom's astronomer Martin Rees, who also has published some really interesting papers with Bernard Carr that we were just looking at. And so early on, he was pointing out that, these jets, these extremely bright central bulges of galaxies, and even the composition and nature of the galactic halo are probably the result of the activity of a supermassive black hole at the center. And just an interesting aside, in my article, The Rotating Universe, there's this very interesting observation where those jets from these quasars have a very strong correlation across parsec and even megaparsec distances. And so, this is quite a surprising finding that these jets of these quasars are aligned and strongly correlated. And, what could cause such strong correlation? Well, one reason is that just as at the Planck scale, you have a multiply connected space-time geometry, a micro wormhole network. It's a fractal organization. So at the larger scale, here at the cosmological scale, you have a multiply connected space-time geometry, a macro wormhole network. These supermassive black holes, they obey a wormhole metric. They are wormholes. So these are probably connected via Einstein-Rosen bridges, and you can see that strong correlation via their pole alignment. And as well, if you have a rotational component of the universe, that is a coherence generating dynamic angular momentum that will cause poles to align as well. So this could be evidence of a larger rotation of the universe itself. Galaxy size is correlated to the size of the supermassive black hole in the galactic nucleus. The more massive a galaxy is, the heavier its central black hole. So no black hole, and you have these little tiny galaxies, dwarf galaxies even. So you need a black hole to form a galaxy in many senses, in many regards. And the larger that central supermassive black hole, the larger the galaxy, the host galaxy. So, that's a pretty direct correlation, and it's a very direct indication that the evolution and development of the galaxy is a result of that galactic engine at the center, the supermassive black hole. Even the presence and prevalence of life within a galaxy is possibly regulated by these active galactic nuclei. Astronomer Avi Loeb has performed calculations for the probability of dispersion of bioorganisms via galactic panspermia. A process that seeds the galaxy with terrestrial planets and potentially living organisms. He notes, so he's done calculations on the survival time of extremophile organisms on dispersed terrestrial objects, life-bearing objects traveling with velocities greater than 100 kilometers per second. He notes, though, in particular, interactions in the galactic center between the supermassive black hole and a stellar binary can accelerate stars to thousands of kilometers per second. And it's been shown that the same mechanism can accelerate planets up to tens of thousands of kilometers per second. Assuming planetary systems have asteroids and comets, dynamical interactions with the black holes can eject them at extreme velocities, and thus they may traverse the entire radius of the Milky Way in 1 million years, approximately. Such hypervelocity objects can become intergalactic. However, the capture probability for an intergalactic object is extremely low. If bacteria and other possible extremophiles have sufficiently long survival times, the galactic center can act as an engine for panspermia and seed the entire galaxy. So we're not just talking about, regulating the brightness of the central bulge and properties of the galactic halo and matter and energy emission via the polar jets. The galactic nucleus, the supermassive black hole at the center of the galaxy, is probably one of the main engines seeding the galaxy with life, galactic panspermia. And his team has done some really phenomenal calculations for this, where calculating the speed of these interstellar or intergalactic objects dispersed via the supermassive black hole at the center of the galaxy, and the capture rate as a function of their velocity, higher velocity, lower potential capture rate, as well as a function of the potential survival time of living organisms on these terrestrial objects that are dispersed through the galaxy. But it's based on his team's calculations, it's totally probable that many planetary systems are seeded with life via dispersion of life-bearing terrestrial objects from the galactic center. And, just as a note, the supermassive black hole at the center of the galaxy, it has a habitable zone around it where terrestrial planets will have liquid water. The only difference with the habitable zone of a supermassive black hole and that of a regular star is that the habitable zone of a supermassive black hole can host 1 million planets because it's that large. So 1 million planets in stable orbit around the supermassive black hole. So, these are interesting considerations when we're talking about the seeds of creation and galactic engines.